This is Bowles here. This video is about potential energy diagrams, which go along with kinetics and also thermo in chemistry. So when you're looking at a potential energy diagram, even just a real simple one like this one, there's certain things that you're going to need to be able to label, and they are listed here. The products, the reactants, EA, which stands for the energy of activation, I and AC, that's known as the intermediate or activated complex, something called delta H, otherwise known as delta E, for the forward and the reverse reaction, as well as EA prime, that little apostrophe means prime, and whether or not it's endo or exothermic. So let's get started. A couple of important things here. The reaction proceeds from left to right. So the reactants on the left are, the products are on the right. And that's because the reaction starts on the left, makes its way up and over to the right. The very top of the curve is known as the intermediate activated complex, or sometimes called the transition. All right, and that would be in the forward reaction. Let's continue with our labeling. So here we have labeled something called EA. EA is the activation energy or energy of activation. You can label it on the front of the curve or underneath the curve. It's basically from the reactants to the top of the curve. And then the reaction, once it reaches the top of the curve and the energy needed to get the reaction going, or activation energy is put in, immediately it will form products. And then you have this thing called delta H or delta E labeled here. And that is called the change in enthalpy or energy of a reaction. It's the difference between where you start and where you end. And it lets you know whether or not a reaction will be endo or exothermic. We went over this before. So if the reactants start low and the products end high, energy must have gone in. So this one represents an endothermic diagram. Let's take a look at this one. On this one, we're labeling the reactants, labeling the products, labeling, again, reminding you that the forward reaction is when reactants form products. The reverse reaction is when products reform reactants. So if you were looking specifically at the reverse reaction here, the reverse. So the reverse reaction would actually start at the product, go up the hill in the opposite direction. That's called energy of activation prime, EA prime or apostrophe. And the delta H or delta E is the same. The big difference between these is if the forward reaction is endothermic, like this one is, then the reverse reaction is exothermic. They're always going to be opposite of each other. Endothermic in the forward, exothermic in the reverse, and delta H and delta E are always going to have the opposite sign. So endothermic is a positive delta H, exo would be a negative because heat is being lost. Let's look at a couple more details here that would be helpful for you. So delta E and delta H are the same thing. If you want to know them, you can subtract the product's enthalpy or energy from the reactants, and that'll let you know if the reaction is exo or endo. Endothermic always has a positive delta H. Exothermic always has a negative delta H. Now, things like the energy of the transition or intermediate, those are always positive. So remember, delta E and delta E reverse are exactly the same amount of energy. They just have opposite signs. So if the forward reaction is endo, it would be positive. The reverse reaction is exo, it would be negative. And keep in mind, activation energy, that's the energy it takes for a reaction to occur. And EA prime is in the reverse direction. So here's the second potential energy diagram for you. Would you be able to label all those same things on this diagram now? The products, the reactants, and so on. Here would be your answers. So the reactants are, of course, at the left, and then you would go over the hill, and the hill is called activation energy. At the top of that hill is what's called the intermediate. At the very bottom now, when it goes all the way down, is where the products are. Delta H and delta E are red and green here. The forward direction is losing energy. So the forward direction is exothermic this time. And the reverse direction would be endothermic. So EA prime is larger than EA. The signs of delta H and delta H reverse are the same, are opposite signs. So the forward direction would be a negative delta H, and the reverse direction, which is shown in green, would be a positive delta H. And that's pretty much how you do it. Now you need to keep practicing, because the more you practice, the better you get. So if you were looking at energy diagram 3, how would you be doing here? Showing you the reactants, showing you the products, showing you the EA, the delta E. Notice you can show it in different spots, but you're still showing it in the same area of the curve. Here's another energy diagram. By the way, the one we just saw, endo or exothermic. Starting high energy, ending low, exothermic. It's losing heat from start to finish. Here's number 4. A few things are labeled here. Would delta H be positive or negative on this one? It starts with reactants of low energy, ends at products of high energy. So delta H, change in enthalpy or energy, would be positive in that one. How about this one? Starts high, ends low, energy was leaving. Guess what? Exothermic. And this quick thing I'm going to finish up with shows you what is different about a reaction in which a catalyst is used. You've heard about catalysts in biology before. Those are enzymes used to speed up reactions. Well, in chemistry, they're also speeding up reactions. They may just be a chemical. It doesn't have to be an enzyme. But basically, the way they do that is by lowering the hill that has to be climbed in order for a reaction to occur, or the activation energy. Catalysts always lower a reaction's rate by speeding it up by lowering the activation energy. And that is about it. The next thing you're going to see is a practice quiz, but I'm going to put that in your slides for you. You can check yourself and see if you're ready with this one. All right, my friends, I hope that helped. Good luck.